All right, hi everyone, this is chapter 8.9, relativistic energy. So relativistically, energy is still conserved. And as you know by now, conservation of energy is one of the most fundamental concepts in physics. So in this introduction, we're going to talk about some of the new formula associated with energy when we talk about object going at very high speed. The first formula we're going to deal with is the rest energy, and this one is often associated with Albert Einstein. It's a very famous equation. It's E is equal to mc squared, or in reality, the rest energy is equal to mc squared. What Einstein discovered is that mass itself contains energy. In fact, this is why stars emit a huge amount of energy. It's because they convert mass back into energy. All right. The second concept is the relativistic kinetic energy, and this one is equal to gamma minus 1 multiplied by the rest energy, or mc squared in this case. Now this formula has an interesting consequence. Let's look at the formula for the relativistic factor gamma. So we know gamma is equal to 1 divided by square root of 1 minus v squared divided by c squared. Let's have a look at what happened when we increase the velocity. When we increase the velocity, that term here get bigger. When that term get bigger, that term over here gets smaller. When that term over here gets smaller, gamma get bigger. So what that means is as the velocity tend to the speed of light, gamma will tend to infinity. All right. Let's go back to our relativistic kinetic energy formula. If we look here, if gamma tends to infinity, that means that the kinetic energy will also tend to infinity. In other words, if you want to get close to the speed of light or at the speed of light, you will need to provide an infinite amount of energy or an infinite amount of work. Well, there's no such thing as an infinite amount of work. In other words, it's impossible for a massive particle to reach the speed of light. In other words, nothing can go faster than the speed of light. It is the absolute speed limit in the universe. All right, so let's combine everything we've seen so far into one concept. We're going to talk about the total energy. And in this course, we're not going to deal, well, at least this section of the course, we're not going to deal with the potential energy. We are only going to take into account the rest energy and the kinetic energy. So the total energy is equal to the kinetic energy, I use that version of the formula, plus the rest energy. We can combine both of them because of the minus 1 over here. And we get the total energy is equal to gamma multiplied by the mass multiplied by the speed of light square. So it's a convenient form. In the next few videos, we are going to be solving some problem using these concepts. All right, so see you in the next video.